Great. So now we are at 2.3 and 2.4 for grade 8. It's a pretty easy review since it incorporates a lot of concepts that we learned last year in grade 7 math, but at least we'll be able to move pretty quickly. There are several sections to this lesson, and what we'll just be going over right now are the first three sections, and then the last two sections we'll be going over in class. So the first one is looking at equivalent ratios, and so if we're given a topic, if we're given a ratio between items, we can set up an equivalent ratio to find out the missing items, and using a scale factor method or using cross multiplication in order to solve that problem. So here is the first problem. To make pancakes, you use the following ratio: 6 pancakes to 1 cup of mix to 0.7 cups of water. How much mix and water are needed to make 120 pancakes for the Christmas breakfast? Use a scale factor method. So what we'll need to do first of all is just rewrite all of our information in our notes. So 6 pancakes to 1 cup of mix to 0.75 cups of water. Then right underneath it, we're going to put down all the stuff so this is all the knows. And now what we want to put are the want to know. We could either put it underneath or we could put it beside as well if we had enough room, and then just make our arrows go sideways. I tend to, especially since we have a ratio that has a three-part ratio, to stack it this way, since if we go sideways you have a lot of arrows trying to go around the place. So what we want to know is, of the things that we need to know, or we want to know, we know that we want 120 total pancakes. We don't know the amount of mix and we don't know the amount of water. However, given that we know these two, those two we can use to make a comparison. So we have to try to find out how to get from 6 to 120. As we learned last year, that if we look at proportions, they only relate through multiplication or division only. Which means we can't add in a proportion. We have to be able to multiply, just because if you look at a picture and you stretch it, you have to look at the dimensions, and both of the dimensions change at the same rate in the same increments. So if we look from 6 to 120, we find out that the scale factor is times 20, and that means the scale factor for the other two will also be times 20. Because it's a proportion and a ratio is in proportion, all of the factors have to be the same. 1 times 20 is 20 cups of mix, and then 0.75 times 20 is 15 cups of water. A pretty standard, easy question when you have all the knowns and unknowns as well. So now let's look at question B. Solving in fraction form using scale factors or multiplication. So that was ratio form, letter A, where we have these colons. Instead, we can make ratios in fraction form. So Greg looks at nutritional information of Chips Ahoy and sees that 4 cookies contain 14 grams of fat. How much fat is found in 28 cookies? So we're going to set up a ratio of what we know and what we want to know again. And what we know is the current ratio: 4 cookies contain 14 grams of fat. Well, first of all, we have to decide which one goes on the top and which one goes on the bottom, or what's in the numerator, what's in the denominator. Well, normally, if we remember from last year, what happens in the denominator is the independent variable, and in the top is the dependent variable. Independent means the stuff that we choose. So we can control the amount of cookies that we choose to eat. We don't really control the amount of fat that's found in each of those cookies, but we do control the number of cookies we eat. So we're going to put the 4 cookies in the denominator. Now, in this particular example, it actually doesn't really matter where you put it, but it's good to know so that there is a preference in terms of where you would want the ratio to be set up, or how the ratio is to be set up. The dependent, what changes because of the amount of cookies, is the amount of grams of fat that's found in those cookies. Now, what we want to know is, we want to know how much fat is in 28 cookies. Well, if we look at our units, we want to put cookies in the denominator. And we know it's 28. What we don't know is the amount of fat that's found in it. So there's a couple ways to solve this. The first way is called scale factor. So scale factor is just like above, where we find out how much we have to multiply each side by in order to get the other side of the proportion. Well, we see the left side, the bottom, or the denominator, we have to multiply by 7, and what we do to the bottom, we have to also do to the top. That means our unknown, let's just choose the letter n grams of fat is equal to 14 grams times our scale factor, which is 7. So that means our total grams of fat will be 98 grams. Another way that we can use is called cross multiplication. And cross multiplication uses a simple formula or a simple rule where you start at the n and you make a fish going around to the other side. So n equals, now we start at the other end of the fish and we cross multiply through and divide down or up, whichever direction we're going. That means we start off with 28 cookies times 14 grams of fat divided by 4 cookies. So if we fill out this multiplication, if we look here, 28 times 14 because we're going across and then down through 4, it gives us n is equal to 98 grams of fat as well. Okay, we can also, what I want you to do is try looking at number 3 and see if you can solve it on your own. Once you end up solving it, you'll find out, choose a variable t for time. And once you solve this problem, you'll see that time is equal to 58.3 bar minutes. This kind of includes a little bit of the previous lesson as well. If you're not sure how you got that, try out the problem to see if you got the same answer. Letter C. So now we include totals in our equivalent ratio. So for example, a coin pouch contains nickels, dimes, and quarters and has the ratio 4 nickels to 2 dimes to 5 quarters. If the whole pouch contains 55 coins, what is the total value of the pouch? Well, first of all, let's put our nose and want to nose on the top and on the bottom. So what we know is that 4 nickels is in proportion to 2 dimes is in proportion to 5 quarters. What we want to know is, well, first of all, if the whole pouch contains 55 coins, what is the total value of the pouch? Well, pouch. So right now, we don't know the value of this. We have values of 4 nickels, 2 dimes, and 5 quarters, but we don't know where this 55 fits in, and we don't know the value. So we're actually stuck with a lot of unknown information. However, what we could do is what we want to know, or what we're trying to find out, is that we have a total of 55 coins. So we're going to include a 4th column, which is called the total column. And what we do know is the total number is 55 coins. That is in our want to know. Now, if we look at this problem, we see that we actually have no partners. Nickels, we don't know how many nickels there are. We don't know how many dimes there are. We don't know how many quarters there are, but we do know how many total coins there are. Well, given this, we can now actually fill out a little bit of information based on this total. Because the ratio total, if we look at 4, 2, and 5, that makes a total of our initial ratio. So the total number of coins in just our initial ratio is 4 plus 2 plus 5. That total is 11. Now we have a partner. Now we know that the 11 total coins in the proportion will balance or will partner with the 55 total coins in our actual problem. Given that, then now we could find out that our scale factor is times 5. So that means all of our scale factors will be times 5. And now we can find out the actual number of coins. We have 20 nickels. We have 10 dimes. And we have 25 quarters. Now, does that solve our problem? The problem asks, what is the total value of the pouch? Well, we do know that there's 55 total coins. We now know the distribution. We know what each of these coins are. Now we actually have to find the value. So the value of each of these coins, 20 nickels is 20 times 5 cents. Plus, I'll put it in brackets just so that we can see it clearly, 10 dimes is 10 times 10 cents, and 25 quarters is 25 times 25 cents. So if we add this all up, this is $1, or 100 cents is $1. 10 times 10 cents is, again, $1, or 100 cents. 25 times 25 cents is 625 cents, or $6.25. If we add this together, our total value of the pouch is $8.25. So given the total, this is a very important part to add into our proportion, we can then balance that out. Here's our last example. What I want you to do is try this out as well in your notes. Try out this problem. Again, it does involve a total. Now, press pause, try out this problem, and we'll give you the answers. After you've tried solving this problem for letter A, what is the mass of each fruit? We have for our pineapple is 80 grams, our cantaloupe is 280 grams, and our watermelon is 120 grams. And for letter B, if it's 1.8 kilograms, well, what we could do is convert 1.8 kilograms and change that to 1,800 grams. And we can, if you're not sure of that, keep it in kilograms as well. And so our answer is for that one, for pineapple is 300 grams, our cantaloupe is 1,050 grams, and our watermelon is 450 grams. Great, so we'll take a look at a couple more problems in class. We'll be looking at D and letters E in class. So if you have any questions, we'll go through that as well.